Hello, everyone. This is test 2 of this year, question 1B. And we're talking about the same gas that we were talking about in part A. So we know the moles and we know that it's monatomic. So you know your CV and your CP in this case here. Now, additional information you're given for this process is that you have a constant volume. So delta V equals 0. You're starting from a T1 of 25 and going to a T2 of minus 29 degrees Celsius. And again, you're trying to find work, heat, delta U, and delta H. Before we look at that delta V function, we want to start with work. This is the one that's going to get crossed off pretty quickly, because you know that your equation for work equal to minus P external delta V. So if that is 0, work equals 0. So there's one done. Now we also know, of course, delta U equals Q plus W. So if that's 0, then whatever we find for delta U will be the same answer as Q. Our equation for delta U, or expansion or compression of an ideal gas under any conditions, is NCV delta T, which would also be heat under constant volume situation, which is the situation right here. We have N from the first part of the question, CV, when it's monatomic, and delta T we can get over here. So your delta T, you don't necessarily have to switch it into Kelvin in this case here, because of the same amount of degree separations for degrees Celsius versus Kelvin. So you can use either in that case right there. This will be equal to 3/2 NR delta T. And if you plug everything into there, so 2.5 moles, and we have 8.314 joules per mole Kelvin. And if you do the math on the delta T, give myself some space here, it's minus 54 Kelvin. So you're going to get a delta U value of minus 1680 joules. And that's the same as your Q. Oops, keep that as a negative. Negative 1680 joules. Last one is delta H that you get from delta Rn CP delta T. You know CP, you know N, you know delta T. So you should get a value here of minus 2180 joules.